Hi guys, good night everybody. Just let me know if you guys can hear me. Alright guys, so again, good night everybody. I see you all say you can hear me, right? So today is the first of 3 live sessions that I'm going to do with you guys in preparation for the January 2025 CSEC Maths exam, right? I know the exam is on Tuesday, Tuesday. So first thing I want you guys to do, please remember to hit like and subscribe for me, please, right? So what I'm going to be doing here, I'm going to be going through a full sample exam here, right? One of my own exams. Basically, it's going to touch on several different aspects of the paper that you guys need to be able to answer, all right? So first things first, let's look at question 1, right? You all should know that the paper consists of 10 questions, right? I know some people are going to ask me, sir, is that the paper coming on Tuesday? Please don't ask that. That is not the paper that's going to come on Tuesday, right? This is my own paper, right? Some of the questions may be similar, right? But this is not the paper that is coming Tuesday. Just letting you know that. Because I know some people are going to ask that, right? All right, so let's start with the first question here, right? Some of you all, you can move along, right? Try to calculate some of the things if you need to. The class has been recorded, so you will have access to the recording on the YouTube channel after, so that's not a problem, right? So this first part here, part A, we want to calculate the exact value of 7 over 12 plus 4/5 minus 1/3. Now let me give you guys a piece of advice here. You see this first part of the question in the exam, right? Please go ahead and use your calculator. A lot of the times they will tell us to use a calculator or otherwise in order to work this out. Don't go and try to work out fractions and all of that. You're allowed to use a calculator, make use of it, right? Let me see if I can pull up this calculator here for you guys. So, right, just to show you what I'm. Right, so I have my calculator up here already, right? And by the way, if you don't, I would suggest that you get a fraction calculator in order to do this exam, right? So the first thing we want to work out, so we're going to put 7 over 12, right? Plus 4/5. Right, and we're going to subtract 1/3, right, and we're going to get this here. So we're going to get 1 and 1 over 20, right? Now you can leave your answer as that, or we can write it as an improper fraction if we want to, right? So you can put the answer as 21 over 20 if you want, right? It's up to you, right? So let's put that answer as 21 over 20. Right, so please go ahead and use a calculator. Don't be afraid, right? Use it. All right, the next part here, we want to calculate 0.05 multiplied by tan 60, but I'm asking you to write your answer in several different ways here, right? Decimal places, significant figures, and standard form. So the first thing I would do, right, is to actually work out 0.05 multiplied by tan 60. So let's pull this up again. Right, so that is 0.05 multiplied by tan 60, right? And we're going to get this answer here, right? 0.0866, and some more zeros. So 0.0866, 0.0866, right? So that's my answer there. But the thing is, we want the answer correct to 2 decimal places, right? Right, somebody saying they thought they would lose marks for not showing you working. No, that's not true, right? That's not true, right? Basically, what they are looking for, they're just looking for the correct answer. If you look at question 1s in the past papers, you're going to see they say using a calculator or otherwise, right? So go ahead and use the calculator. That's not a problem, right? Right, so let me just double check that, make sure we work in here. 0.05 multiplied by tan 60, right? So we get in this here, right? Let's pull this out, right? So I have multiple different screens here. So if you see me moving back and forth, it's because I'm trying to turn on and off certain things, right? Okay, so that's my figure here. Now we want the answer, first of all, correct to 2 decimal places. So if you want your answer to 2 decimal places, it is going to be 0.09, right? Because this 8 here is your second decimal place, right? So if you round that off, we need to look at the 6 here. It's more than 5, so we're going to increment by 1. So it's 0.09. For the second one here, we want 2 significant figures, right? Now, whenever you have a scenario where we have a 0 coming right after the decimal point, that 0 is not significant. So the first significant figure is actually 8 followed by the 6. So if you want your answer to 2 significant figures, it is going to be 0.087, right? That's my answer to 2 significant figures, right? And then the final part here, we want the answer in standard form. So if those of you doing physics will find this easy. So 0.866, right? And you want to write this in standard form here, right? All we need to do is to move your decimal place 2 places to the right, right? You're going to stop after you pass the first digit. So it's going to be 8.66 multiplied by 10 to the power. Because you move the decimal point to the right, it is going to be negative. And you move it 2 places, so it's going to be 10 to the minus 2, right? Right? So it's 8.66 by 10 to the minus 2, right? Right, so that's one part A, one part B, right? Now you all should know that you will get a question giving you some kind of calculation, either fraction or decimal, right? Also in question 1, we do get consumer arithmetic, right? So what's going to come here, you may get something like, you can get wages, you can get bills, you can get appreciation, depreciation. So all of consumer arithmetic, they might put half of the question based on consumer arithmetic. So we have a question here. So Hashika works at a fast food restaurant and is paid a basic wage of $20.50 per hour. A normal work week is 40 hours. Overtime is paid at a rate of time and a half the basic wage rate. On the last week in November 2024, she was paid a total wage of $1,004.50. So the first part of the question says, calculate her basic wage for a normal work week, right? So we want to calculate what's the basic wage for a normal work week. So all we need to do here for this first part, we know that she is working 40 hours. That's the amount of hours that you work in per week. So it's going to be 40 hours. And you're going to multiply that by the basic wage. So this is the basic wage here per hour. So that's $20.50. Right? So when we work this out, we're going to get 40 multiplied by 2050. And you're going to get $820. Right? So this here is $820. So that's how much money she's going to work for, even if she doesn't work any overtime. That's her pay. Right? Part 2 now, we want to work out the number of overtime hours that she worked in the last week, right? Now this is one of those questions where students have a little trouble calculating, but here's what you need to do. We know what she's paid at the end of November, which is this figure. She's paid $1,004.50. Now what you need to remember is that number there is made up of two amounts, right? You have your basic, right? And then inside there now, you also have the overtime, right? So we already know what the basic is. The basic is actually $820, right? So whether she works overtime or not, she's being paid $820. So what that allows me to do here, that allows me to actually work out what is her overtime wage, right? So in this case here, what I'm going to do, I'm going to take 1004.5, and we're going to subtract the basic. So the basic in this case is 820. All right. Again, use a calculator wherever you can. It's allowed in this paper. Go ahead and use it. Right. So $1,004.50 minus 820. So $184, right, and 50 cents, right? So this is actually her overtime amount. That's how much she's working for overtime. Now, here's what we need to do. We need to figure out what is the overtime wage rate. Normally, she works for $20.50, right? So the overtime wage rate, right? That's how much she's being paid per hour overtime. Now, the question says the rate is paid at time and a half, right? Now, you all need to know that there are different ways we can pay overtime, right? Overtime can be paid as either time and a half, which is 1.5 times the normal rate. You can be paid double time, that is twice the normal rate, or you could be paid triple time, or CXC might make up some kind of strange thing we never hear about, right? But those are the basic things here that we normally do. So in this case here, our overtime rate is going to be 1.5, right? That's what time and a half means, multiplied by $20.50. Right? And when you work this out, you're going to get 1.5 multiplied by 2050, and you're going to get $30.75. So this is the overtime wage rate, right, per hour. So we haven't answered the question as yet, because the question says the number of overtime hours. All we need to do is to take the overtime amount, which is the $184.50, and you're going to divide that now by the overtime wage rate, which is $30.75. And this answer here is going to give me what or how many hours did we work. So 184.50 divided by 30.75, and I'm getting 6 hours, right? I saw some of you all put that in the chat already. Yeah, that answer there is 6 hours, right? So that's the amount of that's the amount of overtime there, right? Right? Some of you all say you're taking too long, right? I actually teach people, right? So I take my time and I answer my questions, right? I don't hustle along anything. So that's part C there, right? This is question 2 now, right? So question 2, we want to simplify, right? So we have two parts here. We have 3p squared. 3p squared q multiplied by 5p cube q fourth, all right? So whenever you have a question like this, what you need to do, you need to first multiply the numbers first. So we have a 3 here and a 5 here. So 3 by 5 is 15. And then we have to multiply the p's. So you have p squared multiplied by p cube. You're going to use an indices rule here. So we're going to add the indices. So 2 plus 3, you're going to get 5. And then in the case of the q's now, when you multiply q by q fourth, you're going to add the indices again. So that's going to be 1 plus 4. So this is going to be 5, right? So it's going to be 15p to the 5th, q to the 5th, right? So that's part 1. In the case of part 2 now, right, we have 2x squared all over 3y cubed, and we're dividing that by 12y, right, all over 6x cubed. Right, so this is a division here, right? So you're going to write 2x squared over 3y cubed. When we divide in by a fraction, you change the sign to multiply, and we have to invert. So this is going to be 6x cubed all over 12y, right? Now some things may cancel. So let's see what can cancel here, right? This 3, right, can go into this 2 times, right? This 2 can go into this 6 times, and then this 2 can go into this 3 times, right? So some numbers cancel in here for us. So x squared multiplied by x cubed, you're going to add indices again. So that's going to be x to the power 5 all over. Now at the bottom here, we have a 3 here. And then we have y cubed by y. You're going to get y to the power 4, right? So just feel free to double check the answer. If you see anything looking kind of off key, let me know, right? Right, so that's 2A part 1 and part 2. Question 2 in the exam is going to be based on algebra, right? That's basically what it's going to be based on. Part B here, we have an equation, right? And the first thing we want to do, we want to calculate the value of t when p is equal to 12 and k is equal to 2.5. So this part 1 here is a straight substitution. So all you're going to do, you're going to substitute your k and your p into the formula. So this is going to be 3 multiplied by k. K in this case is 2.5. Right? All over p, which is 12. And you're finding the square root of that. Right? Now let me turn on the calculator here so you see how we work this out. Right? All right, so we're trying to work out the square root of, right, so this is how you're doing this in the calculator. So what I would do, I'll say 3 multiplied by 2.5, right? And then I'm going to divide that by 12. You're going to get an answer, but we have to find the square root of that. So we're going to get this here, right? So the answer for t is going to be 0.7, how much I got? 0.79. Right? Let's put that as the answer. Right? So that's part 1. Right? Part 2 now, we want to make p the subject of the formula. Right? So you all need to be able to change the subject of the formula. So we have t is equal to 3k, right? All over p. And you have a square root here. Now, whenever you have a scenario where we have a square root, right? Wherever we have a square root, we're going to square both sides in order to get rid of the square root sign. If you square both sides, you're going to end up with t squared when you square the left side. On the right hand side, whenever you square square root, the square root is going to disappear. So you're going to end up with 3k all over p, right? And at this stage here, some students get a bit confused and they're not sure what to do. My suggestion is to do this. On the left hand side, you have t squared. On the right hand side, you have 3k over p. What you can do is to write the left-hand side as t squared over 1. Some students might be saying, why am I doing that? I'm doing this so that I can see that I can cross multiply for this question here. So what we're going to do, we're going to say t squared multiplied by p is going to be equal to 3k multiplied by 1, right? Now keep in mind what you're trying to make the subject of the formula. You're trying to make p the subject of the formula. So therefore, if I cross multiply, you're going to end up with p by t squared, right, is equal to 3k. So therefore, if we make n p the subject of the formula, p now is simply going to be 3k, right, all over t squared, right? So that's my that's the formula that I get when I rearrange this, right? Right, so that's part B. Let's see what else we have here. Part C, we have two equations here that we're trying to solve. The first one is 3 open brackets 2x minus 4 minus x plus 1, sorry, is equal to 2. Now, some of you all might be looking at this and thinking, wow, this question is really easy, right? But I've seen students struggle to work out problems like this. Whenever you have an equation, right, that is similar to this, right, and the first thing we need to do is to remove the brackets. So you're going to use the distributive law. So I teach my students in my class to put these arrows here in order to remember what they're going to multiply. So you need to take that 3 and we need to multiply by 2x. We also have to take that same 3 and multiply by minus 4. And for the bracket on the right hand side here, some students may have a little challenge with this, right? Now, in front of this bracket here, there is a 1 that you guys are not seeing, right? You see that little piece here? This is the piece where students are going to get wrong. So there is a 1 here that you are not seeing, but it's not written. But we're going to do the exact same thing to remove the bracket. You're going to take that negative 1 and multiply by x, and you're going to take that negative 1 and you're going to multiply by 1, right? I've seen students make this error a lot of times. So 3 by 2x is going to give you 6x. 3 by minus 4 is going to give you minus 12. Minus 1 by x is going to give you minus x. And minus 1 by plus 1 is going to give you negative 1. And that's going to be equal to 2. Right? So let's leave all the x's on one side and put all the numbers on the next side. So this is going to be 6x minus x is equal to 2. And let's put the minus 12 on the right side. That becomes plus 12. And then we have plus 1. So therefore, 6x minus x, you're going to get 5x. 12 and 2 is 14 and 1 is 15. So therefore, x is going to be equal to 15 over 5. So therefore, x is equal to 3. Right? So that's how you solve a simple problem like that. That is part 1. Part 2, on the other hand, now is a little trickier because part 2 is a quadratic equation. We have 5x squared plus 9x minus 2 right? So there are 4 ways. There are 4 ways of solving a quadratic, right? 4 ways of solving a quadratic. 1, we can actually factorize a quadratic if it's possible as 1, right? The second way is to use a formula. So you all know that formula, x is equal to minus b plus or minus the square root of b squared minus 4ac. But usually CXC will give us a hint when we're going to use that formula. They will normally tell us, write the answer to 2 decimal places. We can also be asked to complete the square, right? So there's several different ways of solving a quadratic, right? So for this one here, it's in question 2, right? But we're going to assume that we can factorize this. Right? So when it comes to the 5x squared, we can put 5x here and put 5x here, right? And we want to get minus 2. So the only way you're going to get that, right, you can probably put 1 here and put 2 here, right? Let's see if that's making sense. 5x by x will give us 5x squared, 1 by 2. So you want to get positive 9x. So that means that we're going to make this a plus and we're going to make this a minus. Let's see if that's making sense. 5x by x will give me 5x squared. 1 by minus 2 will give me minus 2. So far we're good. To get the 9x, it'll be 5 by minus... Oh no, that will work. Alright. Right, this way will work instead. Right? Because you want to get positive 9x. Right? So when I solve this here, what I'm going to get, I will put each bracket equal to 0. So you can say either 5x minus 1 is equal to 0, 5x is equal to 1, and therefore x is 1/5, right? So this is one answer, right? Or we can get a second solution and we can say x plus 2 is equal to 0, and therefore x is equal to minus 2. Right? So when we solve a quadratic, sometimes we may get 2 solutions. Not all the time, but we may get that. Right? Right? Somebody saying they went to primary school with me. Right? From SAGs, right? There are a few people from SAGs. I think there were six students from my class who passed for SAGs, right? Right, so that takes care of question 2, right? That takes care of question 2. Let's have a look at the third question here now. Now your third question in your exam is going to be based on geometry, and chances are they're going to give us some form of geometry in the first part of the question, and then the second part of the question is going to be some kind of transformation, right? So here's what. We have a diagram here, and we have PQR is parallel to ST, right? Determine each of the following given a geometrical reason for each answer, right? For those of you here, right? For those of you here, could you all write down for me what is the value of x? Right? If you all could work out the value of x, please do so. Just write it in the chat. Let me see. Right? All right, a lot of people say the answer is 138. Some people say 125. Let's see which one is the correct answer. So we want to find the value of x here, right? Now the thing is, this line here is parallel to this line, right? So that means that this line here is a transverse line that cuts both of them, right? Now there is a relationship between this angle here and this angle here. Those angles are what we call co-interior angles, right? That means that they're going to add up to 180 degrees here. So we can say that x plus 55, right, is equal to 180 degrees, right? So therefore x has to be equal to 180 minus 55, right? So that's going to be 180 minus 55, and that's going to give me 125. Right? So a lot of people got 138. How come you all got that? 138, right? Right? So what you can say here, these are co-interior angles, right? So co-interior angles are supplementary, right? Meaning that they add up to 180, right? So that's the answer there. That's the value for x. What about y? What's the value for y? Right, I've seen a lot of 42 degrees, right? 42 is the correct answer, right? Y is equal to 42, but you all know the reason why? What's the reason why angle Y is 42 degrees? Somebody said it's the Z angles on them, right? That is true, but the correct word we want to use is alternate angles, right? So here's what's happening. Again, this line here is parallel to this line, right? And this line across here, right, is a transverse line. So therefore, this angle and this angle here has to be the same. Those are what we call alternate angles, right? So make sure you all know about these different types of geometric relationships, right? Alternate angles. All right, so that is part A. Part B, right? We have a diagram here, and the diagram shows three trapezia, right? So we have trapezium P, trapezium R, trapezium Q, and what do we want to find out? Describe fully the transformation that maps P onto Q, right? So you want to map P onto Q. What kind of transformation you all think that is? We're mapping P onto Q. What kind of transformation do you guys think that is? Right, now, I've seen some people saying enlargement, some people saying rotation, right? Now, guys, we are definitely going to get a question on transformations on Tuesday, right? That is for certain. Every single paper, we do get a question on this, right? Now, the question is, what transformation maps, right? What transformation maps P onto Q? So, we have P here, and you have Q here, right? We're trying to figure out what maps both of them. What you're going to notice is that the two trapezia, right? One is just a smaller version of the next one, right? So obviously it's going to be an enlargement, right? But just keep in mind that an enlargement could either make something bigger or it can make something smaller, right? Now, whenever you're reading the question, they said what maps P onto Q, right? So that means you're starting off with P and you notice that it gets smaller, right? Now, you are not going to get all the marks if you halfway describe it, right? So it is an enlargement. So this part one. So it's an enlargement. But some other pieces of information is required, right? You must say enlargement, and you need to say what the scale factor is. Right? You need to say what the scale factor is, and you also need to say what is the center of enlargement, right? All of these things are required in order to answer this question here, right? Right, so it is an enlargement, we agree, right? Because it got smaller. And the scale factor. So the scale factor is simply how large or what ratio am I using in order to scale this image here, right? Now you're going from the bigger one to the smaller one. So here's what you all need to do. All you need to do is take some dimension that you do know, right? So this is 2 units here, right? And this here is 1 unit here. So therefore, since the image is actually smaller than the object, the ratio is going to be a half, right? So the scale factor, right, for this here is going to be a half. It is not 2 because you're not enlarging anything. You're starting off with P and then you're moving to Q. So you're making it smaller, you're shrinking it. So therefore the scale factor is going to be a half. Now the center of enlargement, we can actually work that out. And if you are given that in the exam and you want to work out the center of enlargement, here's what you need to do. Right? My suggestion is this. You're going to take your ruler. Guys, please make sure and work with a ruler in the exam. Eh? Right? Just drawing some lines on this here. Right. So the first thing that we're going to do, we're going to draw these projection lines. Right? So you will allow this to pass through, let's say, this point here and that edge there. Right? Now you need to draw multiple construction lines here or projection lines in order to work out where the center of enlargement is, right? Right? So I've drawn 2 lines here. Normally I draw a few just to make sure we know exactly where the center of enlargement is, right? What you're going to notice is that all the lines, they're going to pass through the same point, right? So based on my diagram here, it seems like most of the lines are passing through this coordinate here, this point here, right? So that's your center of enlargement, and that coordinate is -2, 0. So when you're describing an enlargement, you need to give all of this information here in order to get your full marks, right? Notice I put fully here, right? So once you are saying it's an enlargement, you need to give what the scale factor is, and you also need to see, right? You also need to see what is the center of enlargement, right? Let's see what people are saying in the chat here. Yes, guys, this video will be available after class, right? It takes a while to process, but it'll be there. So that's part 1. Part 2 now, we want to describe the transformation that maps P onto R. Let's go back to the diagram, right? What maps P onto R? So this is what we're starting off with here. This is P and this is R here. What you all think that is? What maps P onto R? Right? A lot of people saying it's rotation, right? Now, you all need to be able to say, right, if something is a rotation or not just by looking at it, right? Now, let me just clean up this diagram a little bit here, right? Let me just remove this here. Right. Now, if we look at P and R, you will notice that P is the same size as R, so therefore it's not an enlargement, right? But if you look at how P is oriented and how R is oriented, you realize something has changed, right? Because the orientation has changed, it means that this here has to be a rotation. So if you're starting at P and you're moving to R, it means that somehow we seem to be rotating this way, right? Now, when you guys are describing a rotation, there are several things that we need to see, right? So the first thing, right, this is part 2, right? So you need to say, you're saying it's a rotation, right? But there's a few more things that we need to give. We need to give what is the center of rotation, right? So we need to know a coordinate here, right? We need to know the angle, and we need to know whether it is clockwise or anti-clockwise, right? Now, based on the diagram here, if you're going from P to R, we know that's going to be anti-clockwise, right? So it's going to be anti-clockwise. So there are 4 things we need to see here in order for us to get the marks, right? So it's anti-clockwise. So we need to figure out what is the center of rotation, right? Now, if you look at the diagram here, right, finding the center of rotation, right, it requires a little effort, right? Now, if I rotate about, let me just show you something here. Let's turn this on. Right. So I hope you all see my screen here, right? Now, if some people, they tend to guess or they assume that the center of rotation is always the origin, right? There are some questions where it is, but let's see, right? Let's say, oh, sorry. Yeah. Let's say we select maybe this point here, right? So that's one edge of trapezium P, right? Right? Now here's the thing. If the center of rotation was the origin, it means that when I were to rotate this point here, it should end up on P, but it's not doing that, right? And that becomes problematic for some questions, right? So here's what I'm going to do. What we need to do, we need to figure out what is the center of rotation, right? Now some students, they have a little challenge with that, right? So try to pay attention to this, review the video if you need to, right? Let me just take off some things here from this diagram. Right, so I need a ruler, right, and I'm going to need a protractor in order to work this out. So the first thing we're going to do, right, we are going to, let's use, I want to use 2 different colors here, right? So what you can do is select 2 points, right, on each image. So let's say we select this point, the corresponding point on image, oh wait, hold on, let me use, I'm going to use this point here on trapezium R, and I'm going to correspond that to this point here, right? I hope that's making sense for you guys. Actually, wait, just now. I'm just trying to make sure I have enough space to draw this here, right? So let me use this point and this point instead, right? So what we're going to do, we want to figure out what is the center of rotation. There's a geometric way we can do that, right? And the first thing we're going to do, I'm joining 2 corresponding points on R and P. That's the red line, right? I also need to join corresponding points. We can use maybe, right? Maybe. I'm trying to use things that I can actually work out on the diagram itself, right? I'm going to choose this point and, not that point, sorry. This point here corresponds to this point here, right? So those are 2 corresponding points on each diagram. What we're going to do next, I'm going to work out what is the perpendicular bisector, right, of each of those lines. When we find the perpendicular bisector of those lines, they're going to intersect at a particular point, and that is going to be our center of rotation. I know some of you all may have never seen this before, right? CSEC has brought this in the exam recently, right? I normally teach my class this in preparation for the exam. So let's find the perpendicular bisector of this line first of all here, right? So if you want to find the perpendicular bisector, you're going to open your compass, right? And open it such that it's more than half the length of the line, right? So this is what I'm going to do. right? So I'm drawing these construction lines here. Then we're going to come across to this side. Right? And the next thing we're going to do now, right? I'm going to draw a line passing through those two intersections, and that's going to be my perpendicular bisector of the original red line that I've drawn here, right? So let's draw this here, right? Right, so I have one perpendicular bisector here, right? Then I'm going to find the perpendicular bisector of the blue line, right? So let's come back, right? So let's make this line blue. So I'm going to find the perpendicular bisector of the blue line. Hopefully that arc is big enough, right? Then we come on this side. And we're going to draw a second arc here now. Right? So when I take my ruler and I draw a line passing through those 2 points there, right? Right? So the intersection of those two lines, right? And when I say those two lines, these are the two lines we're talking about here. You see this one here, this line, as well as this blue line that we just drew here, this one here, right? Where those two lines intersect, that is going to give me my center of rotation, right? So that's this point here. This here represents my center of rotation. It is -2, 0. Right? The center of rotation is -2, 0. So I know some of you all may have never seen this before, right? Normally when they ask us to describe a rotation, they might give us maybe 2 marks or 3 marks, right? Not just 1 mark, right? So this coordinate here is -2, 0, right? So let me just switch this off now. So let's turn back on this and let's take this off, right? So let's go back here, right? So this here was my center of rotation, right? -2, 0. So in terms of our answers, right, it's going to be -2, 0, right? Something else we didn't work out there, we didn't work out the angle, right? But if you all look at the diagram itself, right, that angle there, right, if I were to draw, let's say, a line from here, if I were to draw a line from here to here, and I draw a line from here to here, if you measure this angle here, that angle there is a 90-degree angle, right? So this here is going to be 90 degrees. So to describe the rotation, you need to say what the center of rotation is. It's -2, 0, it's a 90-degree angle, and it's anti-clockwise. All of these things are required in order for us to answer that question, right? So whenever you all see this word here, fully, there's a lot of information that is required for you to get the full marks, right? Let's go back here now. Right. So that's part 1, part 2. On the grid, reflect trapezium P and the line y is equal to 0. So let's go back here. So we have the line y is equal to 0. Now, you guys need to know that the line y is equal to 0 is also referred to as my x-axis. So what I want us to do is to reflect trapezium P in the x-axis. So all you need to do, you look at the distances in front of your mirror line, which is the x-axis. So this here is going to be this here is going to be this, here, and here, right? So if you're reflecting this thing here, it is going to look like this. Now I kind of drawing this freehand here, but please use a ruler in the exam, right? And they tell us to call it P prime, right? So that's a reflection in your x-axis, right? So the x-axis is also referred to the line y is equal to 0, right? So that is the third part. And the fourth part, you want to translate the trapezium using -7, -4, right? So you have a translation vector, right? And it's given by -7, -4. So you all need to know what these numbers mean here, right? The -7 means that you're going to move 7 units to the left, and the -4 means you're going to move 4 units downwards, right? So let's start checking. All you need to do is to translate one point and you can complete the diagram. So -7 means you're going to go 1, 2, 3, 4, 5, 6, 7. So that's -7. And then you're going to move 4 downwards. So you're going to go 1, 2, 3, 4 downwards, right? So therefore, this here will be the top right-hand side of the trapezium. So therefore, I don't need to do anything else. I can go ahead and complete the trapezium, right? So that's here. And then the base is 1, 2, 3, 4. 1, 2, 3, 4. Right? And this here is your P double prime, right? So this one question here, right, teaches us about 4 different things here in the exam, right? Somebody asking about graph paper. No, you don't need to work with any graph book. You are writing on the exam paper, right? You are writing on the exam paper. No need to carry or work with any graph paper, right? All right, so that takes care of the third question, right? Let's move on. All right, so question 4, it's a function question. So I've given you 3 different functions. We have f of x, we have g of x, and we have h of x, right? Part 1, we want to work out f of 3 over 7. So all we're going to do, we're going to substitute 3 over 7, right, into this formula here. That's all you're going to do. So this is going to be 7 multiplied by 3 over 7, right, minus 4, right? 7 by 3 over 7, you're going to get 3. So 3 minus 4, you're going to get -1, right? So you all need to be able to work out simple substitutions like this into any type of function, right? So 3 minus 4 is -1. So that's the answer for part 1. For part 2, you want h of 0. Now this is what h of x is. So you're going to substitute. So h of 0 is going to be 2 to the power x. So that's 2 to the power 0. You all should know that anything raised to the power 0 is going to give me 1. So the answer is 1 for this here. And the next thing we want to work out is g squared of -1. Now there are 2 ways we can work this out. So I'm going to show you the easy way. So g squared is actually a composite function, right? That's what g squared is. So that's the same as saying g of g minus 1, right? That's what g squared means. It doesn't mean I'm going to substitute -1 and the answer I get, I'm going to square it. That's not what it means at all. It's a composite function. So what I would do first, right, I will work out g of -1, right, by plugging -1 into my function g there. So that's going to be 2 by -1 plus 9. So 2 by -1 will give me -2 plus 9. And you're going to get 7, right? Now, we're not going to take the 7 and square it. Please note that's not what we're going to do. So what I'm going to do now, I'm going to take that 7 and I'm going to plug it back into the function. So you're going to work out g of 7 now, right? And that's going to be 2 by 7 plus 9. So that's going to be 2 7s are 14 plus 9. And that's going to give me 23, right? So what I've done here, I've worked out g of -1. It is a composite function, right? So be careful how you're working this out here, right? Be careful how you're working this out here. Right? So that is A part 1 and part 2, right? Let's see what else we have here to work out. We want to work out fg of x in its simplest form. So this is a composite function again, right? So you want to work out fg of x right? Let me just write down what f was and what g was. So f of x is 7x minus 4. Right? And g of x is 2x plus 9. Right? Yeah, 2x plus 9. Okay, so you want to work out fg of x, right? Now, again, this is a composite function, so this is part B here. So we're going to take g and you're going to substitute that into f here. So you're taking g and you're substituting that into f, right? Now, some people have a little trouble visualizing this, right? But all we're doing here, we are taking all of g and you're substituting it into f here. That's what you're doing, right? So therefore, my answer is going to be 7 multiplied by 2x plus 9, right, minus 4, right? So all I've done, I've replaced the x in the function f with 2x plus 9. So we need to remove the brackets. So we're going to take this by this, and then this by this. So 7 2s are 14, so this is 14x plus 9 7s are 63 minus 4. So therefore, this is going to be 14x, right? 63 minus 4 is going to give me 59. So therefore, this is my composite function here, right? This is my composite function here, right? 14x plus 59. Right? So that is part B. Part C, we want to work out what is the inverse. Whenever you all see this here, right? This means we want to work out what's the inverse of the function, right? Now this is an easy one I've given here, right? So let's see part 1. So the first thing we're going to do, right? You want to find the inverse of this function here, right? So the first step is to let y equal to 2x plus 9, right? The next step in the process is to interchange x and y. So we're going to put x is equal to 2y plus 9. And then the final step is to make y the subject of the formula. So I can write this as 2y plus 9 is equal to x, right? So 2y is equal to x minus 9. And therefore y is equal to x minus 9 over 2. Right? So therefore, the inverse function, that's the inverse of g, is x minus 9 over 2. Right? So that's my inverse function here. Right? Right? So this is C part 1. That's C part 1. Right? So that's our inverse function. And part 2, right? Hence or otherwise, determine the value of x when the inverse function is equal to 10, right? So part 2 here, that's how you're going to work out part 2. They're telling us that g, so the inverse function is equal to 10. So therefore, we want to find the value of x that makes that true. So all you're going to do, you're going to put x minus 9 over 2 is equal to 10. Right? So therefore, x is equal to, sorry, I'm jumping a step here. We can say x minus 9 is equal to 10 by 2, which is 20. Right? And therefore, x is equal to 29. That making sense? Hold on, something looking wrong here. Give me a second, something looking a little fishy here. Y is equal to 2x plus 9, x is equal to 2y plus 9, so therefore 2y plus 9, x minus 9 over 2. All right, yeah, that 29 looking correct. I find it was looking kind of iffy now. All right, so 20 plus 9. Right, so we're getting 29 for the answer, right? Those of you asking me to go back, right? That's one. I won't be able to go back. You all can go back to the video if you need to, right? Yeah, 29 is correct, right? Somehow the number looked weird now. That's why I did it over, right? So that's question 4, right? That's question 4. Let's look at question 5. So CXC likes cumulative frequency curves, right? They just like to, right? Right. Somebody said they got a grade 1. Great job, right? So we have a cumulative frequency curve here. It shows the heights of 120 children were recorded, and the data is represented on the cumulative frequency curve below. What we want to do, let's see what they're asking here. We want to determine the median. Could you guys put in the chat for me what you think is the median? Right? All I want to know what is the median, right? Two things, guys. One, so please remember to hit like and hit subscribe, right? There are more than 500 and something students here right now. So I want each of you guys, right? I'm doing this for you guys free of charge. All I'm asking you to do is to hit like and to subscribe to the channel. That's what I'm asking you to do, right? Nothing fancy. I'm not asking you to pay for any class, right? All I'm asking you to do is to hit like and subscribe. So if you haven't done so, please do so for me, please, right? All right, a lot of people saying the answer is 1.6, 1.62. Let's see how we're going to do this. So whenever I ask you for things like median from a cumulative frequency curve, we need to look at what is our largest value here, right? It's 120. So if you want to get your median, what you need to do is to find a half, because median is middle. A half of 120, right, is going to be equal to 60. Now 60 is not a median. Some students believe it is, right? But we need to go to the graph, and we're going to use that 60 in order to work out what the median is. So you need to draw some lines on your diagram, by the way. All right, that's not this. I need a few lines here in order to answer this question properly, right? I need that, and I also need a vertical line as well, an arrow. All right, so first things first, let's read off at 60. So you all need to draw some construction lines on your exam paper if you need to find the median, right? And what we're going to do here, we're going to read off this value from the graph. Now the challenge some students have is trying to be able to read off the graph to begin with, right? Right. So that here, for me, right? Now because you're all watching my screen here, I will accept a range of answers. Right? But for me, it looks like the value just after 1.6, right? Now you need to read this off properly. Some people might say it is 1.62, 1.61, right? But look at the numbers here. This here is 1.6, this is 1.7, and you have 10 lines in between there. So therefore, every small line represents 0.01, right? So that reading there is going to be 1.61 approximately, right? So that's my median. It's going to be 1.61, and your unit in this case is meters, because this is what we're talking about here. You're talking about height, right? So that's the median. Next one, we want to work out the interquartile range. Anytime CXC gives us things like interquartile range, That's a lot of things they want us to work out here, right? Interquartile range, let me back up a sec here, right? So this part 2, interquartile range, and in the exam you don't need to write the full word, you could put interquartile range. It's simply your upper quartile minus the lower quartile, right? That's what it is. So could you all estimate for me what is the interquartile range? Look at the diagram and let's see if you all can come up with an estimate for me of the interquartile range. Right? What we want to know is what is the interquartile range. That's what we're looking for. A lot of people saying 60 is the answer, but that doesn't look correct to me though. Huh? Right? So those of you saying 60, something is wrong in your interpretation. Right? Now if it's one thing you all need to know cumulative frequency. Right? CXC loves this. Right? They like to bring questions on this. Alright, I've seen some people saying 0.1, some people saying 0.09. That sounds a little more probable, right? So here's what. So this here was used to work out your median, or what we call Q2. If you want to work out your lower quartile, what we need to do is to find a quarter of 120, right? So this is going to be 30, right? So that all that does, it tells us where to find Q1, or the lower quartile. If you want to find where the upper quartile is, you need to work out 3/4 of 120, right? So that's going to be 90. Okay, so that's where you all got the 60 from, right? But those numbers there are not, those are not the actual values for the lower quartile and the upper quartile. So here's what you're going to do. So for the lower quartile, right, you're going to come to the graph and you're going to read off at 30. That's what the quarter was about, right? You're coming to the graph here and you're going to read off at 30, right? Now let's see what that corresponds to. According to my diagram here, and we can accept a range of answers like I said, right? So according to the diagram, it's not really exactly on a line. It's kind of in between, right? So I will take my my lower quartile as being 1.545, right? I will take my lower quartile as 1.545, yeah, right? So my Q1 is 1.545, right? My Q3 now, right? The Q3 is going to be read off at 90. So you're coming up here, right? And you're going to read this off here, right? Again, the graph does not pass through exactly, right? Right, like I said, right? CXC will give us a range of answers. So you might get an answer slightly different to mine, and that's also okay, right? So this value corresponds to 1.635, 1, 2, 3. Yeah, 1.635. Right? So when you subtract this here, we're going to get 1.635 minus 1.545. Right? And I'm getting around 0.09. Right? So this here represents my interquartile range. right? If you all have never seen this before, you need to be able to work out what is the lower quartile and the upper quartile. Right? Some people asking why we use a quarter. Well, that's the definition for lower quartile. Lower quartile represents a quarter of our data. Upper quartile is 3/4 of our data. Right? I've seen some people say they never saw this in their life, right? So this is something you all need to know. Yeah, somebody said that's why it's called quartiles. Yes, that's why it's called quartiles, right? So the first quartile is a quarter of the data, right? The second quartile is actually your median, and the third quartile is actually 3/4 of our data, right? Right, so that is our interquartile range. The last part here, sometimes they give us questions based on probability. So what's the probability that a child chosen at random has a height less than 1.7? Now, one of the things you all have to remember is that from a cumulative frequency curve, the curve always gives us less than information, right? The curve always gives us less than information. There are some exam questions where they will ask us about more than, and if they do, you have to be careful, right? So what this is doing here, right? What this is doing here is that the graph only gives us less than. So the question here that I give, right? The question I gave here basically says, what's the probability that a child chosen at random is less than? So we can read this off directly from the graph. So you go to the graph here, and what you're going to do, you're going to read off at 1.7, right? So let's go with this. Right? Now in the exam, you have to draw these lines here. Right? You need to draw these lines in order to be able to get the marks, or at least to read it off. Right? So we draw a line at 1.7. Right? And again, you can give a range of answers here. Right? I'm just going to approximate this here. Right? Right? It's probably a little less, but that's okay. Right? I just want you to understand the concept, right? So let's say I read this off here and I get 110, right? So 110 students has a height less than 1.7. So the probability, so this is part 3. So the probability that the height is less than 1.7, right? All we need to do, we have 110 students. So it's going to be 110 divided by 120, right? So therefore, your probability is simply going to be 11 over 12, right? Now, please, when you're writing on probabilities, either write it as a decimal or a fraction, right? I see a lot of students, they tend to give probabilities as percentages. Try to keep it as decimals or fractions, please, right? Right, so that's the third part. Next part. We have a table here. And the table shows the masses of a sample of 60 oranges, right? So we have 60 oranges here, and we have its group data. We have number of mangoes, and I also included the midpoint in this case here. So the first part, we want to calculate an estimate for the mean. So you all need to know how to calculate mean from a distribution table, right? So whenever you have group data, we need to figure out our midpoint, which is already given to you guys here. That's X. The number of mangoes, right? That's your frequency, right? So for a question like this, we need to work out what is the product of your midpoint by your frequency. So we need to work out XF, right? So you have to calculate that. So that's going to be 8 multiplied by 175.5. You're going to get 1404, right? So I'm actually multiplying these numbers here. So I'm going to take 20. And then I'm going to multiply by 185.5. That's going to be 3710. Then I'm going to take 29 and I'm going to multiply by 195.5. And that's going to be 5669.5. And then the last one is going to be 3 multiplied by 205.5, and that's going to be 616.5, right? Now, what we need to do, we need to add this up. So this addition here is what we call sigma xf, right? So that's plus 5669.5 plus 2710, right? So I'm getting 11,400, right? Now the first part of the question says to estimate the mean. So those of you who have seen this formula, right? Mean is given by x bar, and x bar is equal to sigma xf all over sigma f, right? So sigma in maths mean to add up, right? So sigma xf, we just worked that out. We got 11,400. And you're going to divide that by sigma f. Your sigma f is the sum of this column here, right? Which is how many mangoes we have, right? Oh wait, sorry, I have a mistake in the table here. I'm now seeing that, yes? Right, so this should have been oranges here, not mangoes, right? That's a typo, right? Right, I need to change this, right? So in this case here, sigma f is going to be 60. Is that correct? Hold on. 8 plus 20 plus 29 plus 3. Okay, yeah, right? So sigma f is 60. So therefore, we're going to divide this by 60. Right? And we're going to get 190 grams. Right? So this here represents our mean here. Right? This represents our mean. Right? So that's my mean here, right? That's my mean here. We want to state the modal class. Could you all write down for me in the chat what's the modal class? What is the modal class? Right? So people saying 191 to 200. Let's see if that's true. So once you all see the word modal class, we're looking for where do we have the largest frequency. So in this case here, your largest frequency is 29. So therefore the modal class is 191 to 200. Right? That's it. 191 to 200. That's correct. Right? State the upper class boundary for the interval 181 to 190. Right? Could you all write down that for me? What's the upper class boundary? What's the upper class boundary for the interval 181 to 190? Let me see what you all think is that. All right, people saying 190.5. Yeah, it looks like that to me, right? So the upper class boundary, right? We're talking about this interval here, right? This interval here, right? So it stops at 190, but the upper class boundary is 190.5, right? So you all need to know what is meant by upper class boundary and class limits. This next one here, Tahira estimates that the median is 185. Explain whether her estimate is correct or not. Right? So Tahira estimates, right, that the median is 185. Right? The median is 185. State whether she's correct or not. What do you all think? From the table here, we can actually estimate what the median is. Right? Right, I've seen people saying it's wrong, right? Right, so all right, so a lot of people saying she's wrong, right? So here's what's going on here. We want to work out, or we want to see whether she is correct or not. So median is in middle, right? Now you have a total of 60 oranges here, right? 60 of them, right? So the median, what we would normally do, right? You'll find half of 60, right? And you're going to get 30, right? So what we need to do, we're trying to find where is the 30th, in this case, orange here, right? Where's the 30th orange, right? Now, if you look at the table, you have 8 here, right? If we jump to the next row, we have 20, so we're up to 28. Now, the thing is, she's saying that the median is 185. So she's saying that the median is here, right? But I've only reached up to 28 oranges so far. So therefore, the median is actually not there. The median is really in this interval here, right? So explain whether estimate is incorrect. So it's incorrect. Right? And the reason why it's incorrect is because if we look at the interval 181 to 190, all we are covering is the first 28 oranges. That's it, right? So therefore, she's incorrect. That 185 can't be correct. It has to be between 191 and 200, right? Right? So moving on, right? So that's question 5. Question 6 here, right? So question 6 is always going to be based on measurement, right? A slice of cake is in the shape of a prism. The thickness of the slice is given by h. We have angle AOB is 48 degrees and OA is 7.2 cm, right? So we want to calculate what's the area of the sector AOB. So if you all don't know what we're working out here, this is a sector and you're trying to work out this area here, right? Now there's a formula to work out that. And by the way, surprisingly, this formula is given to you guys in the exam, right? So the area of the sector is given by, we take the angle, right? Let's call it theta, over 360, right? This formula is given to you all in the exam, by the way, and you're multiplying it by pi r squared. That's how we find the area of a sector, right? So the angle is 48, so it's 48 all over 360, right? Multiplied by pi r squared. Normally in the question, they will tell you what to take pi as. Do I have it here? Yeah, so we're going to take pi as 3.14. Need to put that in the question. Right? Multiplied by the radius squared, so that's 7.2 squared. Right? Make sure you all know how to work this in a calculator. So this is going to be 48 over 360 multiplied by 3.14 multiplied by 7.2 squared. Right? And let me know if you all getting the same answer I have here, 21.70. And that area is going to be cm squared. Right? Just let me know if that answer is correct. Right? Yeah, so a lot of people getting 21.7, great, right? Yeah, that's what I'm getting. So that's part 1. And we want to get the length of the arc AB. So the length of the arc here, that's this curved piece here, right? This curved piece here we're trying to work out. So length of arc, right, is, so let's call that L, right? Again, this formula is also given to you guys in the exam, right? So it's given by theta over 360 again, right, multiplied by 2 pi r, right? That's the formula to find the length of the arc of a sector, right? In this case here, the angle is 48 again, multiplied by 2, multiplied by 3.14, multiplied by r, which is given by 7.2. Right, so that's 48 over 360 multiplied by 2 multiplied by 3.14 multiplied by 7.2, and you're going to get about 6.03 cm. right? So that's the length of the arc AB, right? Hope you all getting something like that. All right, great. Right, so that's A part 1, part 2. Let's see what else we have to work out here. Given that the volume of the slice of cake is 195.3, calculate the thickness of the slice. So this diagram here is a prism. So if you want to work out the volume of this thing here, what we do, we take the cross-sectional area and multiply by the thickness of the prism, right? So for any prism, right? So the volume of any prism is given by the cross-sectional area multiplied by the length of the prism, right? That's a formula you all need to know. In this case here, I am telling you what the volume of the cake is, 195.3. Right? And the cross-sectional area, we actually worked that out before. That's the area of the sector. That's 21.70. So this here is 21.70 multiplied by the thickness, right? Now they're calling it H here, so let's use H here. So if you want to work out the thickness, H, right? That's given by 195.3 all over 21.70. So therefore the thickness of this cake here is going to be right, and we're going to get 9s here, right? So this is a really thick slice of cake here, right? So that's the thickness of the cake, 9s here. Right? Somebody's asking an important question here. How many decimal places, right? Usually I tend to give answers to 2 decimal places, right? Do not round off too early, right? Do not round off too early because you may need your answer, right, for another part of the question, right? Right, so that's part B. The next part here now, the slice of cake is covered in chocolate icing on all its surfaces except the bottom. So think about it. If you are icing a cake, right, you're going to ice all parts of the cake except the bottom in most instances. Calculate the area of the slice covered with chocolate icing, right? So we have to look at this diagram here carefully now. So let me just erase some stuff here. Whenever they ask you to work out the surface area of a solid, right, you have to be able to identify all the different parts of this thing here. So what I'm going to do, I'm just going to draw a little line here to help us. Right, this is a 3-dimensional figure, guys. Right, now in terms of faces, right, now we have to calculate. We already calculated the top face, the area of this face here. Now you have this rectangular piece on the side, right? We have another rectangular piece behind, and then we have this rectangular piece here as well. That curved piece there, that's a rectangular piece, right? So once you identify how many faces that we're working with, right, we're going to use that information. So there are 4 different areas we need to add up in order to figure out how much we're going to ice here, right? So like I said, you already worked out the top. You got 21.70, right? So this is part C, right? So you're working out the, right, so total surface area. Actually, I'm going to call it total surface area, right? Area covered by icing. Right? So we have 4 of them we need to account for, right? Now you already have the 21.7, that's the top of the cake, right? Then we're gonna add. So this one here, this face here, right? This is 7.2, right? And the height of the cake, we got, how much you got for the height? We got 9 or something? Yeah, 9. So this here is actually 9. So therefore that's a rectangle here. But that same rectangle is also found behind here as well, right? So you're multiplying, so you have 2 rectangles having the same area. So that's going to be 7.2 by 9, but you have to multiply that by 2. So this is going to be 2. You have 2 faces that are identical. So it's 2 multiplied by 9 multiplied by 7.2, right? So that takes care of 3 faces so far. And the last face that we need to cater for is this curved piece here. Now that curved piece there is actually a rectangle, right? So all we're gonna do, we're gonna take, so the length of the arc is gonna come into play here now, right? So that's 6.03, and you're gonna multiply by the height, which is 9. So this is 9 by 6.03. So plus, right? So we just need to work this out here, and that's going to be the area that is going to be covered by the icing, right? So that's going to be 9 multiplied by 6.03. All right, some people asking what time am I finishing. Well, I'm doing this whole paper, so when we finish all 10 questions, then I will go. Right, seeing people getting 205. Let me just double check that. 9 multiplied by 6.03 plus brackets 2 by 9 by 7.2. Right, so yeah, I'm getting that now, right? 205 point, let's say 6. Right, so that's the area that we have to cover with this thing here, right? Right, let me just answer 1 or 2 questions, right? Right, somebody's asking what year is this paper. So this is my sample paper for 2025, right? What else somebody's asking here? Do I do crash courses for paper 1? Not really, right? I do that in my live online classes, right? What else we have here? Okay, cool, right? So that takes care of that. Question 7, right? Question 7 is always going to be a pattern question, or what CSEC calls an investigation question. So the diagram below shows a sequence consisting of white and gray square tiles, right? So we have white and gray square tiles. We want to study the pattern of numbers in each row in the table and complete the table, right? So we have this pattern here. And we have figure number, we have number of gray squares, number of white squares, and total number of squares. Now figure 4 is drawn for us, right? Because it's drawn for us, right? We can work out the number of gray squares, right? If I count the number of gray squares, so we analyze in figure 4 here, right? So the number of gray squares here is going to be 9. If you all look at it, you see 9. So this here is going to be 9. The number of white squares, could you all tell me how many white squares we have here? While I check it as well. 25, 6, 7, 8, 9, 10, 11, 12. Right? Look at the number of white squares here. Let me know what you all get. I have a number. Right, some people saying 36. I've seen 1 or 2 people saying 45. Let me double check it. I know count the number of white squares and I forget what I get already. Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121, 122, 123, 124, 125, 126, 127, 128, 129, 130, 131, 132, 133, 134, 135, 136, Yeah, I get in 36, right? 36, right? Somehow I counted it and I forget the number already, right? So we have 36 white squares, right? And what about the total number of squares, right? Well, the total number of squares is simply going to add the gray and the white, right? So this is going to give us 9 and 6 is 15. So this is going to be 45 squares in total, right? So we gain some marks here just for filling out the table, right? So this is 45. Now, what I normally tell my class is that when you have to work out this table, I want you guys to work out the last row first, right? Work out the last row first, and then you can work out anything else in the table you want to work out, right? So let's look at the number of gray squares, right? Now, if you notice something here, you will notice that this here is 0, this here is 1, this is 4, this is 9, right? So 1 is a square number, 4 is a square number, right? So you want to work out what is the formula to work out the number of gray squares, right? So all we need to do here, right, if we say n minus 1 squared, right, that is going to be our formula in order to calculate the number of gray squares, right? And you can check it. If I take figure 1 and I subtract 1, I'm going to get 0. 0 squared will give me 0. If I check for figure 2, it's going to be 2 minus 1. Right? 2 minus 1 is 1. 1 squared is going to give me 1. Right? So far the formula holds. 3 minus 1 is 2. 2 squared is going to give me 4. And 4 minus 1 is going to give me 3. 3 squared is 9. So that formula there is correct. We need to work out this formula here as well. Right? Now to work out this formula here, right? What we need to do, right? We need to see what's happening with the total number of white squares. So in this case here, right? When I jump from here to here, I am adding 8. When I'm jumping from here to here, I'm adding 8, right? And when I jump from here to here, I'm also adding 8, right? Now, these are the best patterns we can get in the exam. Whenever there is a constant increase, right, we can figure out what the formula is. So that 8 needs to appear in the formula. So it's going to be 8n, right? Now, we need to test something here. You want to get 12. So it's going to be 8n plus 4, right? So some of you are wondering, how does man get that by? So anyways, right? Anyways, so all we're going to do here, right? We're going to use that information in order to work out this thing here, right? So 8n plus 4, that's going to be our formula. Right? So this is what we call the investigation type question, right? So now, let's work out, so we need to work out the rest of the table, right? So for the rest of the table here, right, we have 36, right? So we need to figure out what's the figure number here, right? So for this figure number here, right, all I'm going to do, I'm going to put n minus 1 squared, right? That's the formula. And you're going to put that equal to 36. So therefore, n minus 1 is equal to the square root of 36, which is going to give me 6. And therefore, n is going to be 6 plus 1. So therefore, n is going to be 7. Right? So therefore, this corresponds to figure 7. Right? If you want to work out the total number of white squares in that figure, it is going to be 8 multiplied by 7 plus 4. So that's 7 8s are 56 plus 4. And you're going to get 60, right? So 60 is going to come here. And the total number of squares, well, if you want to work out the total number of squares, all we're going to do, we're going to add the 36 plus the 60, and you're going to get 96, right? We're going to get 96, right? Right? We leave out this one for now, right? We leave out this one here for now, right? I don't want to complicate the question, right? So whenever you get a question like this, right, try to recognize what the pattern is, right? Tomorrow I'll do an next one, and Monday night I'll do an next one with you guys, right? So that's number 7, right? Question 8 is typically our functions questions, but usually in the form of a graph, So we have two straight lines P and Q here, right? And what do we want to work out? The first thing we want to work out is the coordinates of the x-intercept of the line P. So if we look at the graph, are we looking at line P here? You want the x-intercept. Could you all write down the coordinate for me here? Right? Alright, so some people, so make sure when you're given a coordinate, you have to give me two numbers, yeah? So this here is where the line cuts the x-axis, and that coordinate there is minus 2, 0. Right? So this x-intercept here, make sure you all write it. Some students mix up the numbers. So it's minus 2, 0. What's the y-intercept of line Q? What's the y-intercept of line Q? What is the y-intercept of line Q? Right, so people saying 0, 3. So this is line Q here, and it's cutting the y-axis at this point here, which is 0, 3. Right, so the answer for this one here is going to be 0, 3. Right, part B, we want to work out the gradient of the line P. So let's go to the graph. So if you want to work out the gradient of line P, we need to choose 2 points, right, on line P in order to do that. My suggestion is you already know this point here and you know this point here, right? So I'll probably work this question right here. So the 2 points that we're going to use will be negative 2 and 0, right? And I'm also using 0, 3, right? Now, whenever you are working out gradient, right, what I suggest you do is to label the 2 points properly before you substitute anything. So let's call this x1, call this y1, let's call this x2, and let's call this y2, right? So if you want to work out the gradient m, right, is given by y2 minus y1. This formula is not given to you in the exam, so you need to know it. That's how we work out the gradient of any straight line. So our y2 here is going to be 3 minus 0, and this is going to be x2 minus x1, which is 0 minus 2. So therefore, this is going to be 3 over 2, right? So that's a gradient here of line P. That's a gradient of line P, right? I hope that's making some sense, right? Right? 1 or 2 people have a negative sign, but be careful, right? Look at how P is sloping. P has a positive gradient based on how it's sloping. So we'll accept 3 over 2, we'll accept 1.5, right? We'll accept 1.5. All of those answers are acceptable, right? But it's not a negative slope, right? Now, line P is perpendicular. So they're telling us something here now. Line P is perpendicular to Q. Determine the equation of the line Q. So the gradient of P, right, we got 3 over 2. Right? Now because P is perpendicular, right, it means that this angle here is 90 degrees. Whenever two lines are perpendicular, if you multiply their gradients, you're going to get negative 1. That's a relationship between two lines which are perpendicular. If you multiply the gradients, you will get negative 1. So if the gradient of P is 3 over 2, what is going to be the gradient of Q? Right, so I've seen some answers here. So what's happening here, you can work out the gradient of Q, right? So the gradient of Q, what we invert and put a minus sign in front. So it's going to be minus 2/3, right? So that's a gradient of the line Q, right? Since Q is perpendicular to P. So the question wants us to work out, determine equation of the line Q. So equation of any line is given by y is equal to mx plus c. So this is going to be y is equal to, the gradient in this case here is going to be negative 2/3, right? Now the thing is, from the graph here, we can actually determine what's the y-intercept. The y-intercept is given by 0, 3. So therefore, there's no fancy calculation involved here. It is going to be negative 2/3 x plus 3. That's it, right? So this one is not as difficult as some people think it is. That's all we do. Right? Let's see what else we have to work out here now. All right, so in question 8, we can also be asked to complete the square, right? And this one is a harder complete the square. So we have 1 minus 6x minus 3x squared. Right? Now, there are various ways in which we can complete the square, right? How do I know I have to complete the square? Once you see a question where they ask us to write it in this format here, that is completing the square, right? Now, there's one method that I show in my class, but there are multiple methods by which you can work it out, right? So whichever method you are comfortable with, you stick to that, right? So the first thing I would do, this is the method I normally teach in class, right? We have minus 3x squared. I'm just writing it over so that it looks like a quadratic for me, right? So minus 3x squared minus 6x plus 1, right? So for me, I need to make it look like this first of all, right? Next step in the process now, I'm going to factor out that minus 3, right? Now, what that means is that I'm going to put minus 3 on the outside here, right? And I'm going to write this as, so what I normally tell students, we have minus 3x squared minus 6x plus 1, right? So what we're doing here, we're dividing everything by minus 3. Right? In the first one here, the minus 3's will cancel, so you'll end up with x squared. Minus 6x divided by minus 3, you're going to get plus 2x. Right? And then we're going to have minus 1/3. Right? So in this case here, we have x squared plus 2x minus 1/3. Right? Next thing I'm going to do, I'm going to start to complete the square. Right? So the first thing, when you're completing the square, you'll have a bracket that needs to be squared. And what's coming in the bracket first is x. And we need to find half of this value here. So that's going to be x plus 1. You're going to write back whatever this term was here in this line. So it's minus 1/3. A negative sign is always going to come here. And it's going to be this number squared. So 1 squared is going to give me 1. So this is going to be minus 3, open brackets, x plus 1 squared, right? So minus 1/3, right? Minus 1, right? You're going to get minus 4/3. And the last step in the process here now is to multiply everything by minus 3. So what I'm doing, I'm taking this minus 3, multiply by this bracket, and then I'm taking minus 3 and I'm multiplying by this, right? So when I work this out, you're going to get minus 3 by x plus 1 squared. And minus 3 by minus 4/3, you're going to get plus 4, right? Now CXC may ask us to write it in this format here. So I'm just going to write it a little differently. So it's going to be 4 minus 3 by x plus 1 squared. Now this is usually a difficult question for most students, right? Yes, somebody's asking, this question is called completing the square, right? It comes ever so often in the exam, right? And if it does come, we have to be able to complete the square, right? Now, this is a difficult one, right? Because we have a negative sign in front of the x squared, right? Okay, so that is part one, right? The next part of the question, they want us to sketch on the axis below, right, what the curve is. And then we also want to be able to state the axis of symmetry. Now, so we have 4 minus 3. So the equation is this. 4 minus 3 by x plus 1 squared. Right? Now this is the completed square. You see this equation here? This equation is actually this. Right? Now once you complete the square, it is very easy to plot a graph. Right? Now if you want to get the equation of the axis of symmetry, we put the bracket part equal to 0. So x plus 1 is equal to 0, and therefore x is equal to minus 1, right? So that's the answer for this part here. That's the equation for the axis of symmetry. X is equal to minus 1, right? Now, what I would do in a question like this here, so this curve, right, is going to look like this. It's a quadratic, but it's going to have a maximum point. How do I know that? You see the coefficient of x squared here? Whenever it's negative, it's going to have a max point. Now the coordinates for that max point here is going to correspond to minus 1 and whatever this constant is here. So it's going to be minus 1, 4, right? So if I want to sketch this here, right? Let's say this is 0. Let's say this is minus 1. 4 might be up here. So what I'm going to do, I'm going to do something like this, right? Just now. Right? And this here is going to be a sketch. You're not actually drawing it, you're just drawing a simple sketch. So what I'm going to do, I'm going to label the max point, which is minus 1 and 4, right? And when they're talking about the axis of symmetry, the axis of symmetry is simply this line here, right? This vertical line that passes through minus 1, right? Now this is a simple sketch. That's all I wanted, a simple sketch, right? Right, so that takes care of question 8. We just have 2 more questions to make it to question 10, right? Right, question 9, right? Question 9. We have a circle geometry question here. So we have A, B, C, and D on the circumference of a circle, right? PQ is a tangent, and they give us some angles, right? Let's see if we can answer some of these things here. So the first angle we want is BAO. Right? Where's BAO? Right. So whenever you guys get a question, right, and you want to work out a particular angle, right, write in pencil where that angle is, right? If you know where that angle is, then you'll be able to work it out. Now here's what's happening here. You see this line here? This is a tangent, right? And this line here from A to O, that's a radius. So the angle between a tangent, right, and a radius is going to be 90 degrees. So therefore, what I do know from this diagram here, I actually know what this whole angle here is. That's 90 degrees. So therefore, I can work out the angle that they're asking me for, right? So the angle BAO is simply going to be 90 degrees minus 90 minus 63, right? That's going to be angle BAO. So 90 minus 63, you're going to get 27, right? So that's 27 degrees here. And in these questions here, they normally ask us to give a reason for your answer. So the reason that I'm going to give here is that the angle between a tangent and a radius is 90 degrees, right? Next thing we want to calculate is angle AOC. Let's go back to this diagram here. So AOC, right? Let me just erase this here. So normally what I do, right, whenever I work out an angle, right, I usually write it on my diagram so I know if I need it, I can use it, right? So that angle is 27. I may need it, right? So you want to calculate angle AOC, right? How can we do that? Well, let me use a different color here. I can work out this angle here, right? I can work out that angle there. Could you guys tell me what is this angle here? Let me see if anybody can figure that out. Right, I see people getting 25. So all we're gonna do 25, right? Yeah, all we're gonna do there, we're gonna take 52, right? And you're gonna minus 27, right? And you're gonna get 25, right? So yeah, you all are correct, right? 52 minus 27. So this is 52 minus 27. Right? So yeah, that's correct. Right? That's correct. And the next thing now we want to get, oh wait, sorry. We're not finished, yes? My bad. That's only part of the problem, right? I didn't work out the question yet. Right, so that angle is 25, right? Now the question is asking me, what the question wants angle, this angle here. AO, hold on, AOC. Right? The question wants this angle here. What you all think that angle is there? Right? Yes, we have a class tomorrow and on Monday, right? Right, people saying 130. So if you want to get this angle here, right? If this is 25, the triangle here is an isosceles. So this is also 25, right? So if you want to work out this angle here, right? That angle there is going to be 180, right? Minus, we need to subtract 25 twice. So 2 by 25. Right? So this is going to be 180 minus 2 by 25 is 50. So you're going to get 130 degrees. Right? So that's correct. So some of you all say 130. Yeah, I agree with that. It's 130. Right? So this answer here is going to be 130 degrees. Right? And the next angle we want to work out is angle ABC. You all should be able to calculate this. What is angle ABC? Right? Some people saying easy stuff. Yeah. So angle ABC is simply going to be a half multiplied by 130, right? And that's going to be 65. So you all need to be able to give your reasoner. So the angle at the center is twice the angle at the circumference. You all need to know that, right? The angle at the center is twice the angle at the circumference, right? Right? So this here, for this one here, it is going to be 65 degrees, right? And the last part, we want to get angle ADC. Where's ADC? Right? So we want to get this angle here. You all should be able to calculate that for me. What is angle ADC? Somebody's asking if you don't put your reason, right? So in these questions here, calculating the angles are usually 2 marks, and you will lose a mark if you don't give the reason, right? right? People saying it's 115, right? Anybody know why it's 115? All right, so some people say, yeah, they know why. All right, so it's so what we're gonna do here, right? If you look at this here, we have D, we have A, we have B, and we have C. Those points all lie on the circumference of the circle, so that makes that figure a cyclic quadrilateral. For a cyclic quadrilateral, opposite angles in a cyclic quadrilateral are supplementary. So that's the reason, right? So if you want to work out this angle here, all we're going to do, we're going to say 180 degrees minus 65, right? And that's going to give me 180 minus 65, and you're going to get 115, right? So it's going to be 115 for that answer here. So 115. And the reason has to do with the fact that opposite angles in a cyclic quadrilateral are supplementary. You all need to say that to get the marker, right? There are some rules that we need to know. All right, so that takes care of, so this is 115, right? So that takes care of all the angles for this question here. Usually in question 9, we have circle geometry first, and the next question is usually on either, well, in this one here, I have bearings, right? So a ship sails from port P to port R, right? R is 75 kilometers from P on a bearing of 140. A lighthouse Q is 56 kilometers from P on a bearing of 106, right? And we want to calculate QR. So whenever they give you information regarding bearings, you need to write the information on the diagram. So let's see. So the point R, right, is 75 kilometers from P on a bearing of 140. What that means is that this whole angle here, right, is 140 degrees, right? So you all need to understand what a bearing is, right? So we draw a north line at the point P, and if you want to go to R, we need to measure the angle going in a clockwise direction. That's 140. We have a point Q here, right? And it's 56 kilometers, and it's on a bearing of 106. Now, that bearing of 106, right? And so I'm going to write this on the inside here. So this here is 140 degrees, right? That whole angle there. But the bearing, when you're heading towards Q, that's this bearing here, right? That bearing is 106, right? Now, the question is asking me to work out what is QR, right? You want to work out the distance QR. So here's what I'm going to do here. What I can do is I can work out this angle here, right? I can work out this angle here by subtracting the 106 from the 140, right? So that blue angle, this angle here, you can work that out by saying 140 minus 106. And you're going to get 34 degrees, right? So this angle here is 34 degrees, right? Now the next thing we want to do, we want to calculate QR, right? So that's this length here, right? Now by now, there are certain rules that we have to use when it comes to bearings. We're either using the sine rule or the cosine rule. In this case here, I'm going to use the cosine rule in order to calculate what is that length there, right? So QR, now I normally tell my class, don't just learn off the cosine rule. You need to know how to apply the rule. So the side opposite the known angle, which in this case is 34 degrees, that side squared, so QR squared, is equal to 75 squared. So this is how I teach my class to do this, right? We're doing it based on the diagram, not based on the formula. So 75 squared plus 56 squared minus, open brackets, 2 by 75 by 56 by cosine 34, right? So we're using the cosine rule in order to work this out here. Now, the cosine rule is given to you in the formula sheet. But some people, even though you have the formula, they can't work it out, right? So what I normally do, I work it out step by step. So 75 squared is 5625, right? Plus 56 squared, that's 3136, minus, and we working out that whole piece there. So that's 2 by 75 by 56 by cosine 34, right? And we get in 6964. Right? You could afford to round off here in the earlies. So QR squared is equal to 5625 plus 3136 minus 6964, and you get in 1797. So therefore QR is equal to the square root of 1797 and we want the answer to how many decimal places? One decimal place, so it's going to be 42.4. Right? Hopefully that answer is correct there. Right? So 42.4, 42.3, that's fine, right? Whatever you get there, work with that. Right? So that's the answer for part 1. Next thing we want to do, we want to calculate PRQ. So where's PRQ? So PRQ is this angle here, right? This angle here is what we want to work out. Now, normally when I'm working a question, especially when it comes to bearings, everything that I calculate, I write it on the diagram. So this here is 42.4 kilometers, right? So basically, I have all the sides of this triangle here, right? And I want to work out a particular angle. So for this one though, I'm going to use my sine rule, right? So I have an angle that we want to work out, and we know the side opposite. I also know that we have 34 degrees here, and that is corresponding to 42.4. So I'm going to use the sine rule in order to work this out. So this first question here was worked out using the cosine rule, right? And the second one, we're going to use the sine rule in this case here. Again, I normally don't tell my class to just learn off the formula. We need to know how to apply the formula, right? So this is part 2, right? And we're using the sine rule in this case here, right? So when you're using the sine rule, we say a length divided by sine of the angle opposite that length. So in this case here, let's go with 56, and let's go with the angle that we're trying to work out here. So 56 divided by sine PRQ, right? And the other length that we know here is 42.4 and sine 34. So 42.4 right? When you're all using the sine rule, right, most of the times you're going to have to cross multiply. So we're going to say 56 by this is equal to 42.4 by sine PRQ. So sine PRQ right is simply going to be 56 multiplied by sine 34, right, all over 42.4, right? So therefore sine PRQ so this is going to be 56 multiplied by sine 34 divided by 42.4, right? And I'm getting 0.739. So therefore PRQ, right, what we're going to do, we're going to find arc sine of 0.739 and you're getting about 47.6. right? Now, usually question 9 in the exam is a little more difficult, right? So it's usually a little more difficult, right? So if you get in trouble with this, I could understand, right? But this question here, right? Yeah, so I've seen a lot of people got 47.6, right? Great. And okay, so we have angles now, right? 47.6 is this angle here, right? This angle here is 47.6. All right, now let's see what bearings they want us to work out. So the first bearing that they want, right? The first bearing that they want you to determine the bearing of P from R. Let's go to the diagram. So the bearing of P from R. Right? So you want to head towards P, right, from R, right? Now on the diagram here, you have to kind of figure out, well, what angle are we looking for? So if you want the bearing of P from R, right, you want to get this angle here, right? That's the bearing that we want to work out. What is the bearing of P from R, right? Anybody know how you're working out that? Right, some people are saying some answers here. So here's how we're going to work out this, right? Now the diagram tends to get a little cluttered, right? But I want you to just see if you can see this, right? Now this north line here, right, is parallel to this north line here, right? So if this angle here is 140, right, I can actually work out what this angle is here, right? I can work out that angle. You see, whenever you have two north lines, right, and they're parallel, right, well, they should be, right, when I add up this angle here plus this angle here, they're going to add up to 180. So if that's 140, I can actually work out this green angle here. So this green angle here is 180 minus 40, right? So that's going to be 140 degrees, right? Oh no, sorry, I wrote the wrong thing. Right? It's 180 minus 140. So this angle here is 40 degrees. Right? That angle there is 140. Right? Now the bearing that we're trying to work out is this red line though. Right? The bearing that we're trying to work out is this red line here. Right? One second, guys. Right? My laptop decided they want to restart right now, right? So that angle is 140, but the angle that we want to work out, or the bearing that we want to work out, is this here. So that bearing there is actually 360 minus 40, right? That bearing is 360 minus 40. So the answer for this part here is going to be 360 minus 40, right? And you're going to get 320, right? So that's my answer for that bearing. For part 4, we want to determine the bearing of Q from R. So the bearing of Q from R, so go back to the diagram. So you want to head this way, right? So the bearing of Q from R, right? How are we working out that one there, guys? Right, the diagram already looks so complicated, right? Hold on. Oh, okay, I now seen it, right? I don't know if you all seeing how you're working that out. All right, I see 1 or 2 answers coming in here. How am I working out that? Look at the diagram carefully. All the information is there, right? You want to work out the bearing of Q from R. So we're starting at the point R here, and you're heading towards Q. So the bearing that we're looking for, I run out of colors here, guys, right? So the bearing that we're looking for is this here. It's supposed to be pink, right? But we're looking at this angle here. All right, excellent job. Some of you guys, right? Some of you all getting this correct, right? Excellent job, right? So all I need to do is actually take 47.6 and I need to subtract 40. That's all I need to do, right? So this answer here is going to be 47.6, right? Minus 40, right? And you're going to get 7.6. I agree. That is correct, right? So well done, guys. All right. Time kind of moving fast, so let me just jump to question 10 quickly, right? We've been here for a while. All right, so 10 question in the exam is based on vectors and matrices. So we have 3 matrices here, A, B, and C. Explain why matrix product AC is not possible. So whenever we're trying to do any matrix product, we need to know about the order of a matrix. So this first matrix here has an order of 2 by 2. It has 2 rows and 2 columns. This one is 2 by 2 as well, 2 rows, 2 columns. And matrix C has 3 rows and 2 columns. So it's a 3 by 2 matrix. Now if you want to work out the product A by C, so if you want to work out A multiplied by C, you need to look at the order of the matrix. So the order of matrix A is a 2 by 2 matrix, and you're trying to multiply by C, which is a 3 by 2 matrix. Now, one of the conditions that must happen in order for us to multiply 2 matrices, this number here and this number here, they must be the same. If they are different, I cannot multiply the matrix, right? So what you're going to tell, if this comes in the exam, you're going to tell them that the number of columns in matrix A is not equal to the number of rows in matrix C. That's how you're going to answer that question, right? So the number of columns in matrix A is not equal to the number of rows in matrix C. That's why it's not possible. That's what you're telling them for this here. The second part, right? The second part, they want us to work out or state the order of the matrix of the product C by E. So if you multiply C by E, right? Now C by E, the order of C is 3 by 2. The order of E is 2 by 2. So this matrix multiplication here though, this number and this number, they're the same, and the answer of the matrix is going to be a 3 by 2, right? So the answer is going to be a 3 by 2. It's whatever this number is here and whatever this number is here, right? So they said state the order of the matrix product C by A, the answer is going to be 3 by 2. And the last part, we want to work out what is the matrix B by E. What's the product, right? Let me get a blank page here to work this one. I don't think I have space. Right, so we have these 2 matrices here, right? And what the question is asking us to work out is the matrix product B by E, right? So to work out B by E, you're going to write 1 minus 2 minus 1, 3. And you're multiplying that by E, which is 2 minus 1, 4, 3. Right? Now, when you're multiplying matrices, always remember that it's row by column. Right? Now I'm going to go through the full details here, but we're going to take this row and multiply by this column here, right? In order to get our first element in our answer, right? So 1 by 2 is 2, and so we're working out 1 by 2, right? Plus minus 2 by 4, right? 1 by 2 is 2, right? Plus minus 8. So 2 minus 8 will give me minus 6, right? So the first number here is going to be minus 6. Then we're going to take that same row, right? The same row here, But this time you're going to multiply by this column here, right? So when you multiply that, how we multiply a matrix, this is going to be 1 by minus 1, right? Plus minus 2 by 3, right? This is going to be minus 1 plus minus 6. So that's minus 7. Right? Just double check my answer if you're getting anything different, right? And the next thing we're going to do now, we're going to switch rows in the first one, right? So we're going to jump to here now. And you're going to multiply by this column here. So that's going to be minus 1 multiplied by 2, right? Plus 3 by 4. Minus 1 by 2 is minus 2. 4 by 3 is 12. So minus 2 plus 12, you're going to get 10. So this number here is going to be 10. And then the last one now, we're going to take this row and you're going to multiply by this column here, right? So this is going to be minus 1 multiplied by minus 1 plus 3 by 3. Right? So that's positive 1 plus 9 and you're going to get 10. Right? So therefore this here is going to be my product. Right? Right? Next thing. Part B here, given that we have a matrix M and they're telling us it's a singular matrix, find the value of P. So one of the things that we can work out with a matrix is something called the determinant, right? But when a matrix is singular, the determinant is equal to 0. That's what this means. The determinant is equal to 0, right? Now, to find the determinant, we normally take this number, multiply by this number. So if I'm working out the determinant of M here, right, it's going to be 3 by 4, right? And you're going to subtract minus 8 multiplied by P. That's how we find the determinant of a matrix, right? And in this case, because it's a singular matrix, you're going to put this equal to 0. So 3 by 4 is 12, right? Minus 8 by P is going to be minus 8P is equal to 0. So this is the same as saying 12 plus 8P is equal to 0. So therefore 8P is equal to negative 12. Right? So therefore P is equal to negative 12 over 8, which is minus 3 over 2. Right? So make sure you all understand what is meant by a singular matrix. Right? Alright. So guys, just remember that the class is being recorded, right? You can access the class after if you want, right? It may take a little while to process on YouTube, but it's available for you guys. You can practice the questions again, right? Pause the video, right? And try the questions, right? If you haven't done so as yet, please remember to hit like and subscribe, right? Please remember to do that. I have 2 more sessions. We're doing a session tomorrow, and I'll also do a session on Monday night, right? We have 1 more part of this question here to complete the paper, right? These are 10 questions that we would have done. So we have a diagram here. The diagram shows a parallelogram OABC, AC and OT intersect at the point S. And they gave us some information here. They said AT to TB is 2 to 1. So this ratio here is 2 to 1. And AS to SC is 2 to 3. So this here is 2 to 3. Now they gave us some vectors here. They gave us the vector OA, it's U, and the vector OC is given by V. Now the first part of the question, we want to figure out what is the vector OT, right? I normally tell my class, if you can't do these vector questions, right, don't bother to get your license, because all we're doing here, we are traveling from one point to the next. That's all we do, right? So because this diagram is a parallelogram, I'm going to put in some information here that I should know because it's a parallelogram, right? So let me just write that in here. So the vector AB, because it's a parallelogram, the vector AB has to be equal to V, right? And since OA is equal to U, the vector CB, right, is equal to U as well, right? That might be required. So the first thing we want to get a vector OT. So where is OT? So OT is this vector here, right? Now the thing is, from the diagram, I can work out the vector AT, right? Now AT, right, this vector here, this vector AT is part of the line AB. Now this AB is divided in a ratio 2 to 1, right? Now it means that the line AB is divided into 3 equal parts. So therefore, if I were to break up the line AB into 3 equal parts, that's what it's going to look like. So I can figure out the vector AT based on that information. So the vector AT is really 2 parts. So it's going to be 2 parts out of the 3. So it's going to be 2/3 of the vector V, right? That's the vector AT. And I'm getting that based on this information here, right? So the vector AT is actually 2/3 of the vector V. Now, you want to figure out, the question is asking me, what's the vector OT? So based on the diagram, you need to come up with your vector equation in order to get this, right? Just want to make sure you all see my screen. Yeah. So you want to work out, you want to work out the vector OT. So OT, right? If I want to travel from O to T, I can go from O to A, right? Think of it as driving from one location to the next, and you're going to go from A to T, right? So that's my vector OT. Now OA, right, is given by U, right, plus the vector AT, which we know. We just worked that out here. So it's U plus 2/3 V, right? So that's the answer for the first part. That's my vector OT. The second part, we want to work out the vector OS. Right? Now, where is OS? So the vector OS is this vector here, right? Now, let's look to see what's happening here, right? Now, if you want to work out the vector OS, right, I can figure out OS by traveling from O to A and then from A to S, right? Now, why would I want to do that? So what I could do, I can work out the vector AC, right? Let me see if I could write this on the same page here. I can work out the vector AC. So the vector AC is equal to, right? You want to go from A to C. So you can go from A to O, right? And then from O to C. Now this is typically the most difficult question for most students, right? So the vector AO is in the opposite direction. So you're going to put minus U, right? Plus the vector OC, which is V. So that is the vector AC here, right? Now, remember the objective is to figure out OS, right? But I can figure out what AS is. I can figure out what AS is based on this statement here. You see the line AC is being divided in a ratio 2 to 3. So therefore, you're breaking up that line into 5 equal parts, right? I want you to understand what we're doing here. Whenever you see a ratio, you're breaking up the line into, in this case here, 5 equal parts. So AS, right, that vector AS, right, is going to be 2/5, right, multiplied by whatever the vector AC is, which in this case is minus U plus V, right? I really didn't want to do it on this page here because it's going to look a little cluttered. But this is going to be minus 2/5 U plus 2/5 V. Right? So that's my vector AS here. Right? I hope that making sense to you guys. Right? I hope so. Right? right? So that's my vector AS. So we want to work out the vector OS, right? So OS, let's work this out here. OS, right, from the diagram is equal to OA plus AS. Right? So the vector OA is given by U, right? Plus, we're going to add that now to AS, which we just worked out. That's negative 2/5 U plus 2/5 V. Right? So this is going to be 1 minus, or U minus 2/5 U, right, is going to give me 3/5 U. Plus 2/5 V. Right? So that's my vector OS here, right? I hope that making some kind of sense. If you're not sure about it, right, like I said, look back at the video, right? Right? Usually question 10 is the most difficult question for most students, right? So if you're having challenges, right, that's normal. Right? Now, the last part of the question, students generally leave this out, right? We want to prove that OS and T are collinear, right? I know students from my class would know what this word means. Whenever you guys see collinear, what does that really mean? Right? So whenever you all see the word collinear, right? Collinear simply means that they all lie in the same straight line. So we have O, we have S, and we have T, right? And they all lie on the same straight line. Now the thing is, you know the vector OS, right? You know the vector OS, and you also know the vector OT. Yeah, so we worked out OT and we worked out OS, right? So once you know OT and OS, we can use that information in order to prove that these 3 points are collinear. So let me write down what is OT. So the vector OT was U plus 2/3 V. Right? And the vector OS, right, was 3/5 U plus 2/5 V. Right? So all we need to do, right, there are 2 things we need to show here, right? We need to show that the vector OS, right, is equal to K times the vector OT, right, or vice versa. We need to prove this, right? Now the vector OS is equal to 3/5 U plus 2/5 T V, sorry, right? And that K here is what we don't know, right? Multiplied by the vector OT, which is given by U plus 2/3 V, right? Now this K here, we need to figure out what that K is, right? Now if you want to get 3/5 U, right, it means that K has to be equal to 3/5, right? Now let's double check that and see if that's really true. If I put a 3/5 in front here, and I multiply by U plus 2/3 V, right? This by U will give me 3/5. This by this here, right? You'll get 2/5, I'm sorry, you get 2/3, right? Will you? What's the number? Oh no, sorry, you get 2/5, right? So what we're saying here, based on that information, we are saying that OS, right, is equal to 3/5 multiplied by OT, right? So what we've done here, we've shown that one vector is a scalar multiple of the other, right? So here's how CXC wants us to answer this, right? So since OS, right, is a scalar multiple of OT, right? So since OS is a scalar multiple of OT, they are parallel. Right? And since, so there are two things required in order for you to get this marks here. And since the point O is common, right? So if you look at the two vectors, you have O common to both of them. So since O is common to both of them, to both vectors, right? We're going to say that O, S, and T are collinear, right? This is what CXC will want us to see in order to get the marks here, right? All right. So guys, so we've just completed a full exam paper here, right? Your biggest challenge on Tuesday is going to be time. A lot of students, they have difficulty finishing the paper. That's problematic, right? So it's about 2 hours and 33 minutes, right? The exam paper is usually 2 hours and 40 minutes, right? But at the same time, I'm trying to explain how we're coming up with the answers as well, right? So guys, please, if you have not done so as yet, please remember to hit like and subscribe, right? Go through the video when you can, right? We'll have a next session tomorrow at 8 o'clock, right? And those of you who are interested, my exam preparation for physics, chemistry, and admaths, they are in progress, right? So for the next 4 months, I'm going to be preparing my classes for the May 2025 exams, right? All right, guys. So again, please remember to hit like and subscribe, right? So that's it for me for tonight, right? I hope this session was helpful, right? But enjoy the rest of your night, guys. Be safe, right? And I will see you guys tomorrow at 8 p.m., right? Take care, guys. Yes, there is a complete video on vectors on the channel, right?